Yes, thank you, everybody. Also, lovely to see you all. Big green button is probably forward, I'm assuming. So lovely to see you all and lovely to see those people online. Fantastic that you're here as well. Yeah, so my job is just to kind of introduce DARE again. All of you probably might know that already, but just in case. And to talk a little bit about what we have achieved over the last 4.5 years. And DARE is an ARC Industrial Transformation and Training Center, was funded for 5 years in 2020. We have Sally Cripps here, who was definitely the initiator of this whole project and this whole center. And that's why we invited her to be here today as well. The real goal of DARE is, of course, the training of higher degree by research students, PhD students, to transform the industry. That was the real major aim that DARE has to achieve, and that's what DARE has really focused on. But as a result of that, we also have built this community of data scientists. We brought together all the CIs across both the data science and domain sciences, where we particularly focused on these areas of water, minerals, and biodiversity. So the idea was to bring together the specialists in these different domain areas with the specialists that we have in data science to see if we can make this cross-cutting, cross-disciplinary work where we actually start really applying data science to these challenging problems that we have in the natural resources area. And so as a result, we have managed to develop this combined data science and domain science methods to really make them implementable for industry challenges. That's what we've been trying to work on, and that's what our PhD candidates have been working on to try and develop these kind of approaches. So we feel that DARE has a proven track record of successful collaboration across 5 universities in the end. We started off with 3 and we added 2 others for small as minor partners as well. And we have a range of different core industry partners that have supported this throughout the center's lifetime. So it's really been quite a successful collaboration so far. Just to throw up a few numbers, I don't want to bore you with all the statistics, and this is only a little snapshot. I could talk for hours about what we have done, but we have about 17 PhD candidates, or we have 17 PhD candidates from across the world. And we also had multiple affiliated postgraduate candidates who would kind of come in and join some of our workshops and deal with and associate with the things that we're doing. And a key thing that was developed as part of DARE was a set of bespoke coursework areas, specifically in data science for the PhD level. And I think that still, we kind of forget that because that was all the way at the beginning, but that was a major achievement. We actually put together that coursework and we delivered that to 3 cohorts of PhD students. We trained them up in these data science methods. So that it's just something we don't want to forget, that actually was a key part of what DARE achieved. We have 8 core industry partners, but we also have developed several new industry connections and partnerships. And we've been working with some of these newer partners as well. As output, we published more than 200 papers over with the CI so far. We've provided several public comments on data science and natural resource policy to show that we have clear ideas about where we think that should go. And also specifically the work of many of our research engineers, both our research engineers, we developed several wonderful workshops and capacity building tools that we rolled out through a series of meetings and with different PhD candidates, but also to industry. So there's a whole bunch of work that's also recorded and is online, somewhat online, where we actually work with this, trying to build some capacity in this area as well in data science. So right now, if we look at success, we have 6 of the 17 PhD students who have submitted, and 3 of those are actually already confirmed as having their PhD and being Dr. such and such. We have several more to be submitted actually in early 2025. So there's a few others who are not here because they're working very hard on their PhD submission. And we actually, from the graduates several of those are already employed by major industry partners. So that's another really good thing as well. So we think that all the remaining PhD candidates are on track. Yes, we are, aren't we? We are on track. And we're aiming for, say, a minimum 15 completions by August, because there will be a few who are a bit lagged and they will end up slightly later. Another major thing, I think, which is really important and was a major achievement for DARE, is that we had all PhD candidates to get them involved with industry and trying to get them to complete work and get them to complete work placements. And the work placements, particularly, I want to highlight the work that Kelsey and Carolyn have done in that to try and get agreements up with the different organizations and make sure we had agreements with those for those work placements. And they managed and ran a lot of that, those work placements, and making sure that they were on track. So that's a key thing that we do. So work placements actually took place with many agencies and industry partners, the BOM, Data61, WOBSI, DQ, Water New South Wales, McKinsey and Company, and Xylo Systems. I'm probably forgetting one or two that were also people went to, but yeah, that was quite good. And most PhD candidates, as part of that work placements, actually either delivered internal or external presentations about the work they were doing. So they were communicating also the work they were actually doing at that work placement, and developed often posters. Here's one example of that. And most of the feedback we got from the work placements from both the industry, but also from the PhD candidates, was overwhelmingly positive. They all went, we learned something, but also from the partners where we actually learned something as well. So it was a really good experience, and I really was very encouraging, you know, and in the end, that I thought that was a real good success that we achieved. Here's some examples of those. Yi, who's here, she worked with Water New South Wales, understanding the value of high-frequency automated sampling to derive water quality loads. Vihanga Gunadasa, who's not here, she worked with DQ, the Science and Economics and Insights Division. I'm just got to remember what the acronym stands for. And that was predicting plant species richness to guide repair and restoration. Emma and Megan worked with McKinsey and Company, looking at causal inference using Bayesian networks and transfer learning opportunities using Bayesian models. And Maria Lopez, who will be online later, worked with WOBSI and the Western Australian Museum on characterizing and mapping subterranean fauna. So there's just some examples of that work. And there were many other examples. And maybe when you talk to some of the PhD candidates who are here, or the graduates, then they can tell you what they actually were doing and what they did. Now, the other part that we need to do, not just the PhD training, we also have to help with industry transformation. So we did a series of projects that we worked on to try and help the transformation of industry. And so, for example, we developed some workflows for Newmont to help them process climate and catchment data. So it's more like automating their data ingestion and seeing how that works and making sure that they can check the data. So that was one of the projects we did. We did some workflows for Water New South Wales to estimate license volumes for underground mining losses, right? And we presented that and made sure that we delivered that so they can use that now and actually do some work with that. We did some workflows for New South Wales NRAD, the Natural Resource Access Regulator, and with water technology, Hydro, working on estimation of dam filling using satellite data. We worked on estimating uncertainties in catchment water accounting related to rating curves. We've worked with EDSSN, and also with New South Wales DQ and Water New South Wales. So there's a series of these little projects that we worked on. And here are some other ones where we assisted Minaroo early on. There was a project right at the beginning. We started looking at delivering the Global Fishing Index report, and we did some follow-up work on that and trying to look at whether that methodology could be, you know, generalized and could be made more rigorous. So we looked at that as well. There's a bit of work going on around post-fire camera trap image data analysis, looking at, you know, what we can see on those images, whether we can actually characterize that quickly. Is there any change that we can detect? Looking at web tools to analyze climate variation, agriculture productivity. That was actually some work we did for some international partners in Uruguay, and looking at spatial temporal species distribution modeling with New South Wales DQ. So you can see there's a series of projects there that are kind of, you know, helping these partners develop new technologies and new capacity to try and deliver some of the work that they're trying to do. And I think probably the follow speakers might develop or say more about this. Data science is really still developing, right? We're still not yet finished with what actually data science can deliver, and there's a lot of still new things that we could do and could implement that, right? And so, yeah, the question is this the age of the chatbot, right? Now that we have also DeepSeek, right? And we have ChatGPT and several others. So now, are we now actually going, we've got Copilot, you know, are we actually in the age of the chatbot? So artificial intelligence and machine learning are developing really, really rapidly. but there are still some limitations. And there's an interesting short little paper from Mark Buchanan there, where they talk specifically about the challenges in terms of making sure that AI actually tells you what you want it to tell you, and not tells you something that's maybe not directly related to what you want. And how do you validate that? How do we make sure that we actually know what it's telling? And there's some issues there. And decisions require models in the end that can infer and analysis. We don't just want to know a prediction, but we also want to know why, and we want to know what if and what next, right? We don't want to just talk about here's a number. We want to actually know, why do we get that number, or what will happen next? And I think we still struggle to use uncertainty effectively, right? We talk about uncertainty, we talk about how we should use uncertainty, but we still struggle to actually what we're actually doing with that uncertainty. We can calculate it, but then what next? How do we actually use that to make the decisions? I think there's still work to be going on there. And so using uncertainty, reduce uncertainty, working on adaptive sampling, and looking at inference using uncertainty. I don't want to spend too much time on that because I'm not the expert data scientist. I'm the hydrologist who works with data science. But in the end, I think we also need faster algorithms for uncertainty quantification for most applied problems, because when we look at applied problems, they tend to actually be quite complex. The models tend to be quite complex. So how do we actually create uncertainty analysis for those? That can be quite hard. We are interested in, of course, continuing some of the work that we're doing with there, and not all of that, will be. We tried last year. We had a big try to bring together some partners and see if we could build on the relationships that we have right now. And so we are investigating further opportunities, including, again, revisiting the idea of putting together an ARC research hub application in 2025. But we're particularly keen just to try and build on the track that we are on, which is continuing to using data science to solve industry challenges. That's really what we want to be able to do. So that brings us already onto my last slide. So I really wanted to have this symposium also as a showcase of the talent and the innovation that we have developed. And that's why it's very much about the postgraduate students. Yes, we have some very eminent speakers as well, but we really want to talk about also there's cohort of PhD candidates who will highlight their work, right? But we're very interested also in hearing what Professor Sally Cripps and Professor Ed Cripps can tell us about what is the present and the future of data science, and where do we go with data science? What have we achieved? What are we doing here, right? We also, I think, with the PhD candidates, we can demonstrate the wide variety of projects and highlighting the really multidisciplinary focus of DARE that we have in DARE. And finally, it also brings together these different aspects that we have within DARE: water, minerals, biodiversity, and bringing that together with the data science elements. So I hope you enjoyed the seminar or the rest of the symposium. I'm looking forward to hearing what the stories are.